Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Yesterday in the
Walaikum salam.
yesterday in the previous lecture, we were discussing hypothesis test of equal expected frequencies. So we solved few examples, and today we are interested in learning hypothesis test of unequal expected frequencies. So let us solve this example. The American Hospital Administrators Association reports the following information concerning the number of times senior citizens are admitted to a hospital during a 1 year period. 40% are not admitted, 30% are admitted once, 20% are admitted twice, and the remaining 10% are admitted three or more times. A survey of 150 residents of Bartow Estates, a community devoted to active seniors located in central Florida, revealed 55 residents were not admitted during the last year. 50 were admitted to a hospital once, 32 were admitted twice, and the rest of those in the survey were admitted three or more times. Can we conclude the survey at Bartow Estates is consistent with the information reported by AHAA? Use the zero point zero 0.05 significance level. Okay, so in this case, if you see previously such information like this 40% are not admitted, 30% are admitted, such information was not there, and we were assuming that these percentages are equal. Okay, in the previous case, when we were talking about equal expected frequencies, so expected frequency FE, we were considering that equal in all given cases. But in this case, you can see the frequencies are different. So expected frequencies will be different. So unequal expected frequencies are there in this case. And how will we make use of these frequencies? Let us see. First of all, when you will, and you know, this information is from sample. So definitely, the first paragraph is the information that we have from our past experience, and in this first paragraph, we are talking about population. And if you see the second paragraph, in second paragraph, we have taken some sample from the population about which we are talking in the first paragraph. And definitely these are the sample values. A survey of 150 residents, so 150 is the sample size. So out of 150 now, he's talking about different seniors who admitted in the hospitals and who never admitted, and so on. So based on this information, that is the sample information, we want to confirm that whatever we are saying about the population, that is correct or not. So you may say this is the uh, local experience, and what we say about the population, that will be the national experience. These are the terminologies that we may use. Otherwise, you may use in your own words. Let's say we are going to solve it in 6 steps. So first step is null and alternate hypothesis. Null and alternate hypothesis. In this case, you see H naught. What will be H naught? There is no difference between local and national experience for admissions in the hospitals. So the word no is there. There's no difference. It means equality will hold in the null hypothesis. Equality sign is there. And in case of alternate hypothesis, the whole statement will be there. But this word no is will not be there. So you may remove this word and the remaining statement will remain same. So there is uh, there is difference. There is difference. There is difference between local and national experience. So local experience is the experience that we will have using the sample information, and we are going to say something about the national experience. Means whatever we are saying using sample, that is correct if you take the whole population of some particular area or the whole country in our consideration. So same will be the case for the whole population. So local based on sample and national means there is whole population there. So there is difference. So is difference means inequality sign is there. So you will write down the remaining statement between local and so on up to in the hospitals lost like this. So this will be your alternate hypothesis. Number two, significance level or level of significance. So it is given level of significance is alpha is equal to 0.05. Then comes third step. You know, from the given information, you can see uh, observed frequencies are there and expected frequencies we may construct. So chi-square test will be used. So test statistic, and you know in the previous example we have used one formula. If you recall that formula, the formula will remain same in this case also. Only the values for the expected frequency will change. So the formula was chi-square is equal to summation within braces there is f observed minus f expected. So observed minus expected frequencies square divided by expected frequencies like this. This is the formula. Then come to step 4. Decision rule. So for decision rule, you have to draw the uh, distribution, and remember this is the chi-square distribution. So chi-square distribution will be like this. Okay, so there is no negative side in this distribution. It starts from 0, and on the vertical axis there are probabilities. You know this. There are probabilities, and this is the chi-square scale, or you may write down chi-square values are there. Okay, so you may see zero point 0.05 is the significance level. So let us draw a line over here. This is alpha 0.05, and you are interested in finding out the critical value that will be at this point. So what is that critical value? For that you have to consult the chi-square table, and in that table, degree of freedom is required. So in this particular case, you have to see that how many categories are there. Okay. So if you see 40% are not admitted, one category, 30% are admitted once, the other category, second category, 20% admitted twice, third category, and the remaining 10% admitted three or more times. So four categories are there. So what will you do? You will write down degree of freedom as k minus 1. Degree of freedom will be k minus 1, and k is the number of categories. So how many categories are there? There are four categories minus 1. So the degree of freedom will be 3. So now if you see the table that I have pasted over here yesterday, yes, this table, you can see over here 0.05. This is 0.05, and the degree of freedom is 3. So come down, see the value is 7.81. So you will write down this value as the critical value. 7.81. So write down here 7.81. So this is your critical value. So now you will write down over here, if calculated value of chi-square will exceed 7.81, comma, the critical value, comma, we would reject, H naught, the null hypothesis. So similar statement you can write down in your own words. This is the decision rule. So definitely, if it will exceed 7.81, then that value will be in the rejection region. So that is the reason that we would reject H naught. And then there is step 5, computations. Okay, so in computations, you see what is required. F observed minus F expected. These two things are required. So how will you construct the table, or how will you write down the table that will give you the information regarding this? So you may write down uh, number of admissions, in the hospital, or you can simply write down number of admissions. Okay, so number of admissions are not admitted. So starting from not admitted means zero admission. Fine. Then there are people who admitted once, and then there are people who admitted twice, and then there are people who admitted three or more times. So one means people who admitted once, two admitted twice, and then three or more. So you can write down three or more. right? And then there will be total, right? Number of admissions. So first of all, you see what are the uh, relative frequencies. So relative frequencies are given basically. So I mean relatively how many admitted? 40%. So these are the relative frequencies. 40% never admitted. 30% once admitted. 20% twice admitted. So if you add these 30 plus 20 plus 10 plus 40, the answer is 100%. So basically these are the relative frequencies. Okay, so you have to write down these relative frequencies over here. Relative frequencies for no admission 40%, so you may write down 0.40 or you may write down 40%. You, in that case you would have to put the percentage sign. Then 30%, 20% and 10%. So 0.30, 0.20, 0.10, and in total 1.00% means 100%. These are the relative frequencies. And then there are observed frequencies. Observed frequencies are the frequencies that we have from sample information. So a survey of 150 residents of Bartow Estates, a community devoted to active seniors located in central Florida, revealed 55 residents were never admitted during the last year. So they were not admitted. How many? 55. 50 admitted once, 32 admitted twice, and rest of those admitted three or more times. So 55, 50, and 32. Sorry, 50. First, what was the first observation? 55,
Yes, sir, 55.
55, then 50,
Then 32.
32, and in total 150. So the difference will be written over here. 150 minus 32 minus this. So what is the answer?
73.
150 minus 55 minus 50 minus 32. The answer is 13. So 13 in the survey, you may say that 13 people were interviewed who responded that we were admitted in the hospital three or more times, right? So these are the observed frequencies, right? And now you are interested in finding out the expected frequencies that you will use in the formula. So FE. Now, see, FE, in the previous case, when we were saying that equal expected frequencies are there, then we simply wrote the total and we divided that total number with the number of categories and we found the expected frequency. So in that case, same values were there against each category. But in this case, as relative frequencies are there, so these relative frequencies will help you in finding out the expected frequencies. Okay, so in this case, what you have to do, you simply have to multiply this relative frequency 0.40 or 40% with total persons who interviewed or people who interviewed. So 150 are the total individuals. So multiply by 150 to see the answer. What is the answer? 150 multiply by,
60.
sorry, multiply by point 4, 60. Okay, similarly, again, come over here, see 0.30 is there. So 0.30 multiply by 150. What is the answer? 45. Next, similarly, this 0.20 multiply by this 150. So see what is the answer. 150 multiplied by zero point 0.2, 30. Then 0.10 multiplied by 150. The answer is 15. Okay, and when you will add these values, it should equal 150. You can check it. 15 plus 30 plus 45 plus 60. Check it. It should equal 150. Is it?
Yes, sir.
Okay, so now you can see, in fact, when you surveyed the field, surveyed the area, you saw that 55 people never admitted in the hospital. Okay, but you were expecting, according to the past experience, in line with past experience, that 60 should be admitted never, or should never admitted. And you may expect, based on the past experience, that 45 admitted once, 30 admitted twice, and 15 admitted three or more times. But actually, this was happening. Actually, this is the situation in the area, that 55 never admitted, 50 once, 32 twice, and 13 more than three times, three or more than three. So these are the expected frequencies, and you can see expected frequencies are not equal. So this is the case where unequal expected frequencies are there. So the issue is that you have to find out these frequencies. Previously, these were equal, and you simply divided the total with the number of categories, and you found the same value over here, as you see in the previous case. Over here, yes, expected frequency. So what you did, 10, 10, 10, and so 60. So one, two, three, four, five, six categories were there, and in total, the answer was 60. So 60 divided by 10. Sorry, one, two, three, four, five, six, six, and 60 divided by 6. The answer was 10. 60, this total, and the number of categories are 6. So 60 divided by 6, the answer is 10. So expected frequency was same in all six cases, but in this case, it is different. So formula will remain same. Simply, expected frequency you will have to find out. Now, in the same step, you have to find out the F naught. Sorry. So as I don't have space onward, so therefore what I'm writing the next column. So that column will be F naught minus FE. This column is required, and then F naught minus FE square is required. And then F naught minus FE square, whatever will be the value, you will have to divide that value with expected frequency like this. So these three columns are also there in the table. So let us see F naught 55 minus 60. 55 minus 60. The answer is minus 5. The answer is minus 5. And then you will take square of this, so it will become 25. 50 minus 45, again 5 but with positive sign, and when you will take square the answer is 25. Then see 32, 30, so 2 will be there, 2 will be there, and you will take square of 2, so the answer will become 4. Then see 13 minus 15, minus 2 is there, and taking square of minus 2 you will have 4 again. So now for this column, f observed minus f expected whole square, so you have to take the square of 25. See what is the square of 25? 625 divided by expected frequency. So expected frequency was 60. Write down 60 over here. See the answer.
स्क्वायर पहले लिया हुआ था ना एक बार, डबल स्क्वायर क्यों ले रहे?
Yes, yes, the value was in square, so there's no need of taking square again because square is there, so don't take square. Simply write down the value. So 25 will be there. So 25 divided by 60. See the answer. Good. 0.41. Sorry. 0.4166. So you may write down 0.42. Fine. Then
Yes, sir.
25 divided by FE. What is FE in this case? 50. No, sorry. This is observed. This is expected. 45. Yes, what is the answer? 0.56 you may write down. As the answer is 0.555 and so on. So next 4 divided by 30. 0.13. And finally 4 divided by 15. 0.26. Fine. So now you have to add these values. 0.42 plus 0.56 plus 0.13 plus 0.26. The answer is 1.37. So what is this? This is your calculated chi-square. This is your calculated chi-square. Okay. So now you can see, you can compare this value 1.37 with the critical value or the tabulated value. What was that value? 7.81. 7.81. Which one is greater? This one. This one is greater. 7.81 is larger than 1.37. So it means that this is chi-square calculated. Chi-square tabulated. This is greater, and the rule is that if calculated is greater than tabulated, then we reject. So this case is the opposite of that rule. So therefore, you will write down, we would not reject H naught. We would not reject H naught. Why? Because 1.37 is there somewhere here. 1.37. I mean, it will be in the exception region. So don't reject H naught means accept H naught. Accept H naught means there is no difference between local and national experience for admissions in the hospital. So you may say that whatever we will find using the sample information that is guiding us or helping us in knowing that uh, no problem. Although apparently the values are different. Okay, I mean 55 is not 40% of those who admitted in the hospitals last year. 50 is not 30% of the people who admitted once. Okay, so apparently these values are not same. Observed values are different, and expected values we found from this information. So although these values are different, but finally we are there at the destination that we can say that there is no difference between the local and the national admissions. I mean, whatever is true in case of sample, that is also true in case of population. Fine. So you have to interpret this in, you have to write down this information in step 6. In step 6, you may write down analysis or hypothesis testing. We are unable to reject the null hypothesis. Thus, we may say that there is no difference in local and national admissions. No difference in local and national experience. Next, the word experience was there. For admissions in the hospitals. This was the statement that was there in the null hypothesis, and you will repeat this over here in the interpretation. Okay. So now you are able to solve other questions where there are unequal expected frequencies. Right? Using the same formula and finding out the expected frequencies using the same strategy. So this is all for today. If there is any question, you may ask. No question?
Yes, sir.
No,
No
sir.
question.
Okay, thank you
Yes,
very
sir.
much.